Right now, your physical brain is sitting in absolute pitch-black darkness. It has the consistency of soft tofu, and it is permanently locked inside a thick bone vault with zero light, zero sound, and zero direct access to the outside world. This is what neuroscientists call the interoceptive inference model. When external stimuli like light waves hit your retina, your brain receives nothing but meaningless electrical pulses. To make sense of that data, it constructs a 3D simulation of a room for you to navigate. Translating those electrical pulses into the sights and sounds you are experiencing right now takes precious milliseconds. Because this processing takes time, the reality you think you are reacting to is technically a playback of the past. You are living inside a biological simulation. You have never actually touched or seen the true physical world directly. The hardware powering that simulation consists of roughly 86 billion neurons, each firing bursts of neurotransmitters like dopamine and serotonin to render your subjective reality. In the 17th century, the philosopher Gottfried Leibniz proposed a thought experiment to understand this system. Imagine taking that biological hardware and blowing it up to the size of a giant mill, so large that you could physically walk inside it. Leibniz pointed out a paradox. If you strolled through those massive, fleshy corridors, you would see gears pushing other gears and electrical signals triggering chemical valves. But you would never find a thought. You would never locate the entity actually watching the simulation. For centuries, anatomists mapped out the mechanics of the machine. Look at this historical drawing of the cerebral cortex. They documented the intricate, labyrinth-like physical folds and the vascular pathways with extreme precision. They found the gears. They found no observer. We can track exactly how a chemical reaction propagates through physical tissue, yet science has zero explanation for how that physical tissue actually generates the subjective experience of being you. To understand the limits of this machine, we have to look at neuroplasticity. This is the phenomenon where the software of your mind actually alters the physical hardware of your brain. Watch how these glowing dendrites actively reach out and forge new links. Specific experiences and thoughts cause the brain to physically rewire its own circuitry, altering the shape of its axons and dendrites in real time. But the system behaves very differently at the extreme opposite edge of human experience. Consider what happens to the mind when the physical machine is starved of oxygen and begins to shut down entirely. On a historical EEG readout like this one, doctors can monitor the erratic, fading electrical signals of a dying organ. The physical data flatlines. Yet, patients revived from this exact state frequently report vivid, hyper-real journeys, known as near-death experiences. This presents a profound paradox. Subjective consciousness seems to persist and occasionally heighten at the exact moment the physical engine is failing. This gap between the physical brain and the conscious mind is known as the hard problem of consciousness. It is an undefeated wall in modern neuroscience. As we pan across the labels on this antique phrenology bust, we are looking at early attempts to solve the easy problem. Today, we can successfully map specific physical regions of the brain to precise physical outputs, like language processing or motor control. But mapping a location tells us nothing about the experience itself. Knowing exactly where language is processed doesn't explain how rearranging that meat creates the subjective feeling of a word having meaning. The relationship between physical matter and subjective consciousness breaks our current understanding of physics and biology. The Human Connectome Project maps the synapses of 86 billion neurons into a digital format. If we copy that structure into a server, is that digital copy actually you, or just another mill with no soul inside? The brain survives by actively predicting the future to anticipate bodily needs before they happen. This predictive engine constantly generates internal error signals. If your blood pressure drops, the brain generates a signal that forces your consciousness to react and correct the imbalance before a crisis occurs. Your mind is an anticipation engine. It uses these error signals to run slightly ahead of time, ensuring the body stays in balance. We see this engine working at its most extreme when you sleep, completely severing itself from waking sensory input. As this surreal environment folds in on itself, consider the mechanics of a dream. Your brain independently generates entire, fully populated worlds for you to navigate, paralyzing your physical body while you live out alternate lives. Step back from Leibniz's mill entirely and look at the human condition as a whole. You are a localized pocket of biological matter that has somehow gained the capacity for internal experience. Look at the physical room you are sitting in right now. The room you see only exists inside your head, a reality constructed